So we're starting on lesson 34. This is graphing linear equations, part 2. All right. So there's several ways to do this in your calculator, but for the most part, it takes longer to do in your calculator than it would be just to do it. Okay. So I want to remind you of the formula for slope. Okay. So on part A, it asks us to find the rate of change. Remember, rate of change is the same as slope. It's just a little bit different word. So remember that that's the same as slope, which is the same as rise over run, which is the same as the difference in y's over the difference in x's. Okay, so to rewrite that formula, because I know a lot of you don't like this one, it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, so this is the one you're most familiar with. If you don't have it memorized already, go ahead and write it down. We're going to do a couple example problems and then move on from there. And I'll remind you of the shorthand way that I do it. All right, so here's your 2 points. It doesn't matter which one of them is your first point or which one of them is your second point, but it must remain consistent. So if I put 2 as the first one, then I must put negative 3 as the first one on the bottom. Okay, so it's 2 minus 0, and then negative 3 minus 0. That was really easy. So I get 2 over negative 3. My slope is negative 2/3. Okay, any questions? Didn't figure there would be. Let's do one in the shorthand way that I showed y'all guys last year, just to remind you. 0, 2, and I stack these points. 0, 2 and 5, 4. And the reason I stack them is because it makes it easier for me to subtract them. So I just write a subtraction in, and I deal with them like 2 separate pieces. So 2 minus 4 is a negative 2, and 0 minus 5 is a negative 5. And then I just take my y, I put it over top of my x, and reduce if I need to. So this one is just 2/5, not thirds. 2/5. Any questions there? It's the same equation, I'm just pulling it apart so that it's easier to see, and I never confuse which one is being subtracted from which one this way. Okay, so I always have the first one on top and the second one on bottom, so I never get them backwards. Okay. Of course, you can use anything that you know how to do. So if you want to graph it and count, rise over run, that's fine. Yes? Say that again. 2 minus 4?
Oh, I thought it was negative 4.
No, I just wrote in the minus right there. Okay. All right, let's go move on to a couple of the different forms that we'll see. Okay, the one that we need to get a little more familiar with, because we're not as used to seeing it, is standard form. So it's capital A x plus capital B y equals capital C. Now, all of these capitals are just constants. They're just some number. They're just constants. Now, these are constants, but A and B cannot be equal to 0. They are not allowed to be equal to 0. Okay? Otherwise, you're not in standard form anymore. C can be equal to 0, but A and B cannot. Okay, so this is called standard form. The one we're most... Yeah, all of them are constants. All of the capital letters are constants. X and Y are just your input and output, but the rest are constants. On slope-intercept form, that's the one we're most familiar with. It's y equals mx plus b. I know y'all guys should know this, but I'm just going to remind you. M is slope, b is the y-intercept, and that is slope-intercept form. And they call it that because it involves the slope and the intercept. They were not really clever when they made these names. The next one is y minus y sub 1 equals m, open parentheses, x minus x sub 1, and close that parenthesis. That is called point slope form. And the reason for that is because it involves slope, and this point involves m, which is your slope, and a point x sub 1 comma y sub 1. The name of it tells you where it's easiest to be used. Okay, now this is just to play off of the slope formula. If you look at this one, y sub 2 minus y sub 1, look at this y minus y over x2 minus x sub 1. Look at this. If I divide this, it's the same thing. And slope is that formula up top that we just got done doing. So this is just a play off of the slope formula. So whenever they give you something in standard form, the easiest way to graph it, for graphing purposes, the easiest way to graph it is using the intercepts. So if you're graphing the x-intercept, that's where y equals 0. If it's the y-intercept, that's where x equals 0. So I always tell you guys to do this x and y chart like this, where x equals 0 and then y equals 0, and you find the opposite variable. You had a problem like that on last night's homework, I do believe. Okay. On slope-intercept form, we're going to graph the intercept, then follow slope. On point-slope form, we're going to graph whatever point they give us, and again, follow slope. Okay? And remember that that's subtraction, so when you see minus 2, that's really just 2. And if it's a positive 2, then it's actually a negative 2 when you graph that point. We'll get into a few examples that will make that a little more clear. Example 2. Get this on the page here. Okay, example 2a says 3x plus 2y equals 12. So first of all, what form is that in? Standard form, right? And in order to graph this, I taught you guys use the x, y staggered set of zeros. If you don't like that method and you want to do a horizontal chart, I'm okay with that. It's still going to give you the same exact answer. So just for diversity here, we're going to do a horizontal one. So I've given it still a staggered set of zeros. I'm going to let x equal 0. So here 3 times 0 is 0. So 0 plus 2y equals 12. And to finish solving that, I just divide by 2. Y equals what? 6. Good. Next one, I'm going to let y equal 0. So the next step, I let y equal 0, and I'm left with 3x plus 0 equals 12. And to get that by itself, I just again divide by 3. And I'm left with x equaling 4. Okay. So in order to make a line, we only need 2 points. For good measure, you might do a third point just to make sure you're doing it correctly. But to make a line, you only actually need 2 points. So after I do that, all I need to do is graph those 2 points. If you want to use my graph stamp, of course, you're more than welcome to do so. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So I need to graph those 2 points. The first one is 0, 6. So I go to the right 0 and up 6. There's my y-intercept. This is my y-intercept. If I want to do my x-intercept, I do 4 over and up none, and simply connect it. There you go. Try to use a straight edge if you've got one, and you should all have one because you have a book. Use the side of it. Any questions on graphing that? Okay. Example B then. On example 2b, it gives us negative 2x plus 5y equals negative 2. 20, sorry. All right, I'm going to test on whether or not you paid attention during the standard form. What is the number that represents b here? B. You go A, B, C. 5, right? What is C? Negative 20. And A? Negative 2. Good. All right. So since we have this, how do I want to graph it? What's the easiest way? Easiest way. What did we just do? Sub in 0 for x and then sub in 0 for y. We graph the intercepts, just as I wrote on the notes. Graph using intercepts. Okay? Some of us don't like graphing using intercepts, so of course you have all kinds of different methods to do. So for this one, instead of graphing intercepts, we're going to solve it for y. We're going to put it in y equals mx plus b form. We're going to put it in slope-intercept form. So I already heard somebody say add 2x, so I'm going to go ahead and add that. 2x is now gone from the left side. What do I need to do? Divide by 5. So divide by 5 on each side. Now, what's important here is that most people will mess this up. So make sure that this 5 is given to everything on the right side. It's just like multiplying. You would have to distribute it. So in this division, we would act like it's a distribution, okay? So it really is 2 separate divided by 5s. So I'm left with -4 and positive 2/5 x. So what is my slope now? 2/5. And what is my y-intercept? -4. So I can graph that rather easily. I go 1, 2, 3, 4 down my y-axis. I graph that point. And then my 2/5 is positive, so I need to make sure that I'm graphing something that goes up. So I'm going to count 1, 2, and then over 1, 2, 3, 4, 5. Put my second point, and then just connect it. We need to become efficient graphers because later on in the year, we're going to start graphing inequalities, and it gets really interesting, but only if we're good graphers. We get to start using it in the form of business and such, where it's actually applicable. All right, example 3. Graphing a linear equation giving the point slope form. So y minus 3 equals negative 1/2 x plus 2. Okay, I could, yes. There's an easier way that involves me doing a little less math. Because I know that the point x sub 1 comma y sub 1 is hidden in this equation, I'm just going to pull it out. So my x sub 1 is this one right here. Because it's positive and it's supposed to be, I'm going to write the original formula underneath it, or on top of it, sorry. Okay, because this is a negative right here, it's supposed to be minus, this has to be a negative. So my x is actually a -2. And then, since this one's already minus, it's just going to be a positive 3. So I have the point -2 comma 3. So I'm going to go -2 on my x-axis and positive 3 on my y-axis, and I just graph that point. Then I need to identify my slope. So my point was -2 comma 3. My slope is what? Looking at the equation, -1/2. So we need to remember that we're going downhill this time. Okay, so I'll just count down 1 over 1, 2, right? And then I just connect it. And by graphing that, I can see where my intercept would have been. So for those of you who wanted to distribute it out and put it in y equals mx plus b, that's a-okay. You will still get the same exact answer. Okay. You can transpose or change every single one of these to a different form. Okay, so if you have one in standard form, you want to put it in y equals mx plus b, or slope-intercept form, you can. If you have something in point-slope form and you want to change to y equals mx plus b, slope-intercept, then of course again you can. All right, example 4. This is where the new stuff comes in, so if you're already working on the lesson, make sure you pay attention. This is talking about the transformation of f of x. Remember, f of x is the same as y, so that would be the same as y equals x. So I want to show you, or remind you, what this graph looks like. Y equals x, they're going to call this the parent function. So y equals x looks like the line that goes directly through the center of your xy axis, which is called the origin. And then it basically just cuts every single one of these boxes in half too. All right, let's see if I can do this without jacking it up. Good enough. Right? So that's basically, with a little bit of fudging, the y equals x function. It goes straight through the origin, it's supposed to go straight through the origin, and then hit every single one of these vertices on their way down. Okay? So, messed it up a little bit, but there it is basically. What we're going to talk about is the translation of any of these. Okay, if you see that this gets a negative, remember what happens with a parabola when it's opening up and it gets a negative, it opens down, right? So all it is changing our slope. So if it gets a negative, our slope will look like that. It'll be just going down. So it's literally a mirror image. Like I folded the paper in half, it would be a mirror image. Okay. If it adds to our function on the outside, okay, so if we see something that looks like this, g of x equals x minus 3, this shifts us along the y-axis. Okay, so this would move us down 3, okay, and it would still hold the same slope. So all it's literally telling us is that it's shifting. Okay, so shifts down. When we get down to something being multiplied by it, so they use this example, g of x equals 2x, this tells us that it's going to start getting higher faster, basically, right? So it's going to go from here up 2 over 1, up 2 over 1, and our slope is going to get higher. So they call this stretched. In the terms of a parabola, we could tell a lot easier that it was being stretched upward. But on this one, it doesn't necessarily look like if I stretch this line. So always think that if it's stretched, it's somebody pulling from the top. If it's being made wider or getting fatter, compressed, it's going to be pulled from the side. Okay? So same rules apply. If the number is greater than the absolute value of 1, it's going to be stretched. If it's less than the absolute value of 1, it's going to be compressed. Okay? So, sure.
Okay, I can't help it. I know that's what.
Okay, if it is less, if this front piece right here is less than, if a is less than the absolute value of 1, a is less than the absolute value of 1. Okay, if the absolute value of a is less than 1, then it is going to be compressed. If the absolute value of a, which is just the leading coefficient to x, is greater than 1, it's going to be stretched. Okay, it's the same concept of when we were dealing with parabolas.
I took one breath. I've been holding it.
All right, so here we go. On part D, they give us the equation, and it's in y equals mx plus b. It's in slope-intercept form. So it says negative 1/3 x plus 2. So this negative tells us that the graph has been transformed or flipped, basically, right? It is a reflection. So when it is a negative, so if it's negative, we're going to call that a reflection. So these are the vocabulary words that you're going to start to use. So it's negative, so it's been reflected across the x-axis. It's been reflected. Because this is 1/3 and it's less than 1, it's been compressed. And then because it's plus 2, it's been moved up 2 units. Actually, I guess the technical word would be transformed, but moved up 2 units. Okay. Questions there? These are a lot easier to read in y equals mx plus b form. So if they give them to you in something other than that, you're going to need to translate them to y equals mx plus b. All right, last thing, and y'all guys can be on your way. You should already know this, but I'm going to remind you. On example 5, they give us the equation y equals a number, which is 3, and then they give you x equals a number, which is negative 2. When I graph these, here's my xy axis. When I graph x equals negative 2, I'm going to go on my x-axis. I'm going to go 1, 2. I'm going to plot a point where x equals 2. And I'm going to ask myself, where else does x equal 2? Well, x equals 2 all along anywhere that it is right here. So I can literally make up any point where x equals negative 2. For example, negative 2, 1, or negative 2, 3, negative 2, 1,375. It doesn't matter. Just make sure that the x-coordinate is negative 2. Okay? So if you say that, you never have to think, oh, is x equals vertical or horizontal? You just ask yourself, where is x always equal to negative 2? and you'll answer your own question on whether it's vertical or horizontal. It's vertical. Okay, so x equals something, it is vertical. On y equals 3, I'm going to count up 1, 2, 3, and I'm going to ask myself the same question. Where else does y equals 3? It equals 3 all along here. So 3, 1,372. Sure. So when y equals something, it's horizontal. Questions, comments, concerns?
No.